Hello class, this is Fire Service Hydraulics and Water Supply, Chapter 4, Water Distribution Systems. There are several objectives we'll cover in this chapter, and only one of them is listed here, but I'm going to read them all out to you. We will be able to list the four basic components of a water supply system. We will list the three rates of consumption that must be considered when determining the capacity of a water system. Explain the two basic categories of water supply sources. Describe the two basic processes that are used to improve the quality of water. Describe the three basic mechanisms for moving water through a water supply system. Explain basic purpose and operations of water main valves for water supply systems. Describe the two basic operating designs for modern hydrants. And finally, discuss the purpose of private water supply systems. And we're going to start now with learning objective 1, which is to list the four basic components of a water supply system. Any municipal or private water supply system has four basic components: a water supply source, water treatment facilities, a mechanism for forcing water through the system, and a system of piping to transport the water through the community. Any community usually has only one water supply system, and it is used for domestic consumption, industrial applications, and fire protection. This is important to the fire service professionals' understanding of the impact of factors like widespread lawn sprinkling and high industrial demands on the amount of water available from hydrants when a fire occurs. There are a few major cities that have secondary water supply systems that are intended solely for fire department use, and typically they utilize high volume, low pressure supplies of untreated or non-potable water that can be used during large-scale firefighting operations. It may not be continually pressurized. The authority operating the system must be notified to pressurize the system when it is needed. Routine fires are handled from the standard water supply system. Some industrial complexes may have special, separate water supply systems for firefighting emergencies, such as refineries, paper manufacturing facilities, or other high fire hazard operations, and they tend to use untreated water to supply these systems. Responsibility for the operation of the water supply system. In other words, the fire department relies heavily on these systems for its success, but rarely does it have a major hand in construction, maintenance, repair, or operation of those water supply systems. In most municipalities, a specifically designated water department manages the water supply system. This department may be an actual division of the municipal government, a separate trust or authority, a private-owned company that contracts with the community. It is important that the fire department have an excellent working relationship with the water system operator to ensure that the fire department's concerns will be addressed when the system is constructed or modified, during critical periods when the system is down, when an additional water supply is needed for a major firefighting operation. So some review questions like we've done chapters 1 through 3. Remember, these are available. I'll give you the page number to look them up, and these will appear on future quizzes and tests. Review question 1. What four things are generally required for a water supply system to move water to a hydrant? That is on page 49 of your text. What are three uses for a community water supply system? That is on page 49 of your text. Learning objective 2, we will list the three rates of consumption that must be considered when determining the capacity of a water system. Water supply systems designs typically take into consideration three basic rates of consumption: the average daily consumption, ADC, maximum daily consumption, MDC, and peak hourly consumption, PHC. The average daily consumption, or ADC, is the average of the total amount of water used daily in a water distribution system over a period of 1 year. The maximum daily consumption, or MDC, is the maximum total amount of water that was used during any 24-hour interval within a 3-year period. The peak hourly consumption, or PHC, is the maximum amount of water used in any 1-hour interval over the course of a day. The maximum daily consumption is normally about 1 1/2 times the average daily consumption. The peak hourly rate normally varies from 2 to 4 times the normal hourly rate. The effect of these varying consumption rates on the system's ability to deliver required fire flows varies with the system's design. Both maximum daily consumption and peak hourly consumption should be considered to ensure that the water supplies and pressure do not reach dangerously low levels during these periods. Adequate water must be always available if a fire occurs. Here's a review question for you. What type of information is typically used to determine a water system's capacity? That will be on page 50 of your manual. Learning Objective 3, we will explain the two basic categories of water supply sources. The water supply system begins with a reliable source for water that can be drawn into the system. Depending on the size of the community and its demand for water, the system may have a single source or multiple sources. Water department officials must monitor and plan constantly for the community's water needs. This should incorporate an engineering estimate of the total amount of water needed for both domestic and industrial use and firefighting use. In large communities, the domestic and industrial requirements usually far exceed fire protection needs. In small towns, the requirements for fire protection may exceed other demands. The two basic categories of water supply sources are surface water and groundwater. Most communities utilize only one type of source, although a few rely on a combination of surface and groundwater. Sources include rivers, streams, lakes, reservoirs, coastal waters, and ponds. Rivers and streams are a very common source of domestic water supply due to their proximity to many communities. They do present many challenges from a reliability standpoint, and available volume is most affected by variations in rainfall. During periods of drought or even minor increases in rainfall, these bodies of water can drop to relatively low levels, resulting in reduced water quality. During periods of heavy rain and flooding, the spreading water can swamp treatment facilities and make the water dirtier. Water officials also must be constantly on the lookout for any pollution that has entered the source upstream of the treatment facility and deal with it accordingly. Treatment and purification processes for water from rivers and streams must be constantly reviewed and adjusted as necessary. Lakes, reservoirs, and ponds are all generally similar from a water supply standpoint. They tend to be stable in water quality, and they're not as quickly affected by periods of rain or decreased downfall such as rivers and springs are. The water quality may decrease somewhat near the shore in shallow areas of the body of water. The rate at which surface water will decrease in volume depends on the size of the body of water, the capabilities of the springs or streams feeding the body, and recent rainfall. Many water departments utilize man-made impoundments that are constructed close to the water treatment facility. These are supplied by raw, untreated water pumped from a remote surface water supply source. Many impurities therefore filter out naturally. Most jurisdictions try to keep these impoundments as full as possible so that maximum water is available in the event of a major fire or emergency. With oceans and coastal waters, these are generally not used as domestic water supplies because the process of desalination and purifying the waters in useful quantities is difficult and expensive. Some municipalities and industries use these sources for dedicated fire protection water supply systems and other purposes. In these roles, they provide for an almost limitless supply of water. Surface water supply sources tend to have softer waters with less minerals than groundwater, and they have more suspended solids and color than groundwater. They can also have more bacterial contaminants than groundwater, and they deplete more rapidly during periods of low rainfall. With groundwater supplies, there are two primary types of groundwater sources that may be used as water supplies for domestic systems: wells and springs. The quality of the water coming from both sources is generally very high. The process of traveling down through the earth to underground source filters the water and purifies it. It requires little, if any, treatment ultimately for purification purposes. Groundwater supply sources tend to have harder water or more minerals than surface water, as we mentioned. They tend to be clearer, have less odor than surface water, and have less bacteria. But they can also be less quickly affected by periods of decreased rainfall than surface water. Some review questions. One of these questions is to list at least 2 general characteristics of surface water. That will be on page 52 of your manual. Another is to list 2 ways that groundwater differs from surface water. That will be on page 53 of your text. Learning Objective 4 will describe 2 basic processes that are used to improve the quality of water. The treatment of water for water supply system is important from a health and safety standpoint. It improves the water's clarity, color, and removes odors, contaminants, and bacteria and other disease-carrying organisms. There are 2 basic processes. The first is adding elements that may improve the quality of the water or removing contaminants that will improve the quality of the water. Water treatment facilities. With a water treatment facility, contaminants can be removed by 4 basic processes. The first is sedimentation, which uses gravities to cause particles to fall out of the water. Filtration, where it passes water through a series of filters that catch and remove suspended matter. Coagulation means that it's typically used in combination with one of the other methods, and it also introduces a chemical to the water that causes solid particles to bond together, forming large pieces. And living organisms in chemical treatment can be removed from the water by chlorination, and other chemicals can be added to remove elements such as calcium and magnesium that make the water hard. They're also added, like fluoride, for instance, is added in the process of chemical treatment. Fire departments and fire protection professionals have very little to do with water treatment. Firefighters' main concerns regarding treatment facilities is that the purification process and a drastic reduction of the volume and pressure of water is not hampered due to a maintenance error, natural or man-made disaster, a loss of power supply, or that a fire could disable the pumping station or stations itself or themselves. Another problem would be the treatment system's inability to process water fast enough to meet demand. A related concern for fire protection personnel regarding water treatment facilities is the bulk storage and usage of hazardous chemicals. Large quantities of chlorine, fluorine, various acids, and other hazardous materials are commonly on site. Pre-incident plans for these facilities must account for these chemicals. Here's a review question for you. Name the 4 methods by which contaminants are removed from water. That's on page 53 of your text. In this learning objective, we will describe the 3 basic mechanisms for moving water through a water supply system. For a water supply system to work, water must be moved from its supply source to the treatment facility. Once treated, the water must be introduced into a water distribution system with sufficient pressure to make it usable. There are 3 basic types of water movement systems that are in common use. First is gravity system, the second is direct pumping, and the third is a combination of the 2. This is an example of a gravity system, which we'll discuss in the next slide. Gravity systems use a primary water source located at a higher elevation than the distribution system. The head pressure created by the higher elevation provides the energy to move the water through the entire system. To obtain sufficient pressure to supply a reliable municipal water supply system, the water source generally must be located at least several hundred feet higher than the highest points in the water distribution system, and it is the least common of the 3 types of systems. Most commonly found in jurisdictions where a system's water supply source is located at the same elevation or lower than the system it supplies is where you will find a direct pumping system. Direct pumping systems are used for 1 or more pumps that take water from the primary source and discharge it through the treatment processes. Another series of pumps forces the water into the distribution system. The types of pumps and drivers to power the pumps will vary depending on the local system. Most commonly used drivers are electric motors followed by diesel engines. The most reliable systems have available both types of pump drivers. Most systems are computer controlled. These regulate the pumps, valves, and other components of the system. They also monitor the demand on the system and adjust to ensure that an adequate flow of water is maintained. Computer equipment must be redundant and have sufficient backups. Booster pumps may be located at strategic points in large water distribution systems to compensate for pressure losses due to friction or elevation changes. The third is the most common type of water supply system in North America, and that's a combination system, rather. Combination systems make up the most common types of water supply in North America, as we mentioned. It utilizes elements of both the direct pumping and gravity systems. Elevated storage tanks supply the gravity flow, and a good combination system requires reliable, duplicated equipment and properly sized and strategically located elevated tanks. An advantage of a combination system is that the water stored in elevated reservoirs can ensure continued supply when the pumping portion of the system becomes inoperative. Elevated storage should be sufficient to provide domestic and industrial demands, plus the demands of expected in firefighting operations. It must also be sufficient to permit making most repairs, alterations, or additions to the system. It should also be placed where the system is most likely to require additional pressure and flow, such as at the ends of long feeder lines, at the outermost boundaries of the system, and near areas that are subject to frequent high demand. The distribution component of the water supply system receives the water from the pumping station and delivers it throughout the area served. In addition to the pumps and elevated storage tanks, the distribution system includes pipes, valves, meters, and fire hydrants. The ability of a water system to deliver an adequate quantity of water relies upon the carrying capacity of the system's network of pipes. There are three common designs for water supply system piping arrangements. They have the tree system, circle or belt system, and a grid system. The tree system contains a central primary supply pipe that feeds branch distribution lines throughout the jurisdiction. Primary disadvantage to this is that most places in the system receive water supply in only one direction. The points toward the end of the branch lines can receive dangerously low flows during periods of peak demand closer to the center of the system. If a break in the system occurs, all customers downstream of the break may completely lose their water supply. With the tree piping system, the primary disadvantage, as we just mentioned, is that most places on the system receive water supply in only one direction. It also points towards the end of the branch lines, and those receive dangerously low flows during periods of peak demand closer to the center of a system. And if a break in the system occurs, all customers downstream of the break may completely lose their water. The circle or belt system, found in small jurisdictions, forms a loop that serves all the customers on the system. In the event of a break on one side of the system, the direction of flow may be reversed to supply the rest of the system, assuming there are no automatic check valves or black flow preventers. This is not commonly used for municipal domestic consumption water supply systems. It's frequently used for secondary fire protection water supply systems in large cities. The grid system is the third type of system, and these are the most modern municipal water distribution systems. They utilize an interloop system of pipes connected at standard intervals to provide a reliable, multi-directional flow of water through the system. A grid system generally consists of the following piping components: primary feeders, which are the largest pipes or mains in the system; secondary feeders, which comprise the network of intermediate-sized pipes that reinforce the grid within the various loops of the primary feeder system; and distributors, which are smaller mains serving individual fire hydrants and blocks of consumers throughout the system. One of the grid system's primary advantages is that most of the fire hydrants can receive water from two directions. This greatly reduces the amount of friction loss in the system and increases the volume of available water. In well-designed grid systems, two or more primary feeders run by separate routes from the supply source to the community's high-risk and industrial districts. This helps to ensure adequate water supply at all times. Secondary feeders should be arranged in loops as far as possible to give two directions of supply to any one point. This increases the capacity of the system at any given point and ensures that a break in feeder mains will not completely cut off the supply to the system. Most piping in a modern distribution system is made up of cast iron, ductile iron, asbestos cement, steel, plastic, or concrete. Piping is almost always installed underground. Pipe should always be the proper type for the soil conditions, pressures, and temperatures to which it will be subjected. When water mains are installed in unstable or corrosive soils or in difficult access areas, steel or reinforced concrete pipe may be used to give the strength needed. Some locations that may require extra protection include areas that are beneath railroad tracks and highways, close to heavy industrial machinery, prone to earthquakes. There's area of rugged terrain. The internal surface of the pipe, regardless of the material from which it's made, resists water flows. Water flow and friction loss created can also be affected by other factors. Friction loss is increased by incrustation of the minerals on the interior surface of the pipe. You can also have sedimentation that settles out of the water. And both conditions result in restriction of pipe size, increased friction loss, and a proportionate reduction in the amount of water that can be drawn from the system. The size of pipes used in systems will vary depending on the size of the community they serve. Here's some review questions for you. The first is, which is the least common type of method of the three basic types of water movement systems? That will be on page 55 of your text. The second is, which type of water movement system is computer controlled? That will be on page 56 of your text. Next review question, what is the advantage of using a combination type water movement system when the pumping portion becomes inoperative? That will be on page 57 of your text. The next learning objective we're going to cover is we will explain the basic purpose and operations of water main valves for water supply systems. The function of a valve in water distribution system is to provide a means for controlling the flow of water through the distribution piping. These can be located at frequent intervals in the grid system, so only a minimum length of pipe is out of service at any one time, and only small districts are cut off if it becomes necessary to stop the flow at any specific point. These need to be operated at least once a year to make sure that they stay in good condition, and inspected and operated on a regular basis. A well-run water utility has records of the locations of all valves. If each fire company is informed of locations of valves in the distribution system, condition and accessibility can be noted during hydrant inspections. Water main valves are divided into two types, indicating and non-indicating. Indicating valves show whether the gate or valve seat is open, closed, or partially closed. These are not common in municipal water distribution systems, but are more frequently found in private fire protection systems. There are two common types, the post indicator valve, PIV, and the outside screw and yoke valve, or OS&Y valve. Non-indicating valves are a type used in the most municipal water distribution systems. It's not possible to tell the position of a non-indicating valve simply by looking at it. When in a water distribution system, they are typically buried or installed in manholes. If buried and properly installed, it can be operated above ground through a valve box using a special socket wrench on the end of a reach cord. Control valves may use either gate mechanisms or butterfly mechanisms. Both mechanisms can be used in either indicating or non-indicating valves. Gate valves may be grouped as having a rising stem similar to the OS&Y valve, or a non-rising stem, where a valve nut is turned by a valve key or wrench to raise or lower the gate and control the water flow. Butterfly valves are tight closing. They usually have a rubber or rubber composition seat that is bonded to the valve body. They are non-indicating, so they require a special type of valve key. And the principle of operation provides satisfactory water control after long periods of inactivity. If valves are installed according to established standards, only one or perhaps two fire hydrants will have to be closed off from service while a single break is being repaired. The advantage of proper valve installation is reduced if all valves are not properly maintained and kept fully open. Valves that are only partially open cause turbulence, resulting in high friction loss. Closed or partially closed valves may not noticeably affect ordinary domestic flows of water. A fire department will have trouble operating water in areas of the distribution system where valves are closed or partially closed. Here's some review questions for you. One is, what are two basic categories of valves used in a water supply system? That will be on page 62 of your text. In Learning Objective 7, we will describe two basic operating designs for modern fire hydrants. A fire hydrant provides access to underground water distribution network for fire protection purposes, and that is its sole job. AWWA specifications are designed to produce a hydrant that is free from difficulties such as trouble in opening and closing, interior mechanical parts that can work loose, leakage, excessive friction loss, failure to drain properly, or loose nipples. The two main types of modern fire hydrants are dry barrel hydrants and wet barrel hydrants, and you see them illustrated here on this slide. Standard hydrants will have at least one large outlet, which is 4 to 4.5 inches or 100 to 112 millimeters for pumper supply, and 2 outlets for a 2.5 inch or 65 millimeter coupling. They're equipped with a 5 inch or 125 millimeter valve opening and a 6 inch or 150 millimeter connection to the water main. The threads on all hydrant outlets must conform to those used by the local fire department. Dry barrel hydrants are used in areas that have freezing temperatures. It has a base flow valve below the frost line, and the stem nut to open and close the base valve is on top of the hydrant. During freezing conditions, a firefighter should visually check a dry barrel hydrant after use to ensure it drains completely. If a hydrant does not drain completely, use dewatering pump to remove the remaining water and report the hydrant to the water department for repair. With wet barrel hydrant, there's usually a compression valve at each outlet, but it may have another valve located in the bonnet that controls water flow to all outlets. They feature a valve at the hose outlet, and this is used in mild climates where prevailing weather conditions are above freezing. Firefighters should be alert for leaks in the following areas at any time a fire hydrant is used. You need to look at the main valve when the valve is closed, at the drain valve when the main valve is open but the outlets are capped, and in the water mains near the hydrant. The actual flow of water from a hydrant may vary due to such conditions as feeder main location, incrustation, deposits, or totally or partially closed supply valves. Okay, here's some more review questions for you. What 2 basic operating designs for fire hydrants are in use today? This is on page 63 of your manual. This is Learning Objective 8, where we will discuss the purpose of private water supply systems. Private water supply systems are most commonly found on large commercial, industrial, or institutional property sites. They exist for only one of 3 purposes: to provide water solely for fire protection, for sanitary purposes, consumption and fire protection, or for fire protection and manufacturing processes. Private water supply systems receive their water in bulk from a municipal water supply system. Some may have their own water supply source and treatment facility independent of the municipal water distribution system. Having separate piping arrangements in a private water supply system offers several advantages, including the fact that the property owner has control over the water supply source, and either system, fire protection or domestic or industrial, is unaffected by service interruptions to the other system. Fire protection professionals must be familiar with design and reliability of private water supply systems in their jurisdiction. Here's some review questions. One is, what are the advantages to having separate piping arrangements in a private water supply system? That's on page 66 of your manual. Thank you as always for your time, class. Should you have any problems, make sure to contact your instructor, and we'll see you for Chapter 5.